All right, welcome back. Mech 1330, Fluid Power, Chapter 13 in your book, last chapter here. All right, so we're going to talk about solenoid valves, servo valves, pump controls. All right, so most of the time when we are controlling fluid power, we're controlling everything with a PLC. Hence, the next course you're going to take is PLCs, or you might be taking it concurrently right now. All right, so where we're going to program our Siemens and Allen Bradley and Mitsubishi PLCs, okay? So remember, a PLC is a programmable logic controller. All right, we've messed with some of those as well when we've done Arduino stuff or FPGA boards or things like that. So PLCs, they monitor the input and generate an output based on the ladder logic that you've written. All right, so we use a bunch of different sensors and transducers and things like that. We've talked about a lot of these in electrical class. You'll talk about them even more in PLC class and things like that. But sensors, right? Those are the interface between the physical components and the electronics. All right, so we use a physical parameter, right? Position, speed, acceleration, pressure, flow, temperature, gas. All those different things, and we convert that to an electrical signal. Okay? So we call them all in transducers, right? A transducer is just a device that converts energy from one form to another. Okay, so it takes fluid pressure, converts it to electrical energy or things like that. All right, but we're going to learn about all those next chapter. We're going to do some labs here in class coming up with this stuff as well. All right, but two basic types of control systems that you will always learn about. All right, we have open loop and closed loop control. So open loop control, all right, we don't use sensors to understand what's going on. And when we do something that's open loop control, there's no feedback, all right? So it's just hoping that whatever we programmed is working and that nothing goes wrong or breaks, because we don't have any way to detect if something goes wrong and breaks, all right? If we have a closed loop system, okay, we use sensors to monitor the system where we get feedback about the system. And we understand, oh, if something's out or something's not working or those sort of things. So we can use closed loop systems to, either correct or troubleshoot systems and see what's going on. All right. Heavy use with solenoids. All right. Remember solenoids from electrical class? We're taking a coil of wire, putting a current through it. That current induces a magnetic field, and we use that magnetic field to open and close the plungers in our directional control valves. All right. And we tell it, we give it our electrical signal from the PLC. All right. If it's a 1, we're going to open the plunger, all right, allow air to flow through it that way. So very common. We did a lot of this in electrical class. We did some labs. Those of you that haven't taken electrical yet, it's okay. I'll show you those on the 870 trainer and some of the other trainers that we're going to use. All right, but solenoid valves, very important for us. We use them in hydraulics as well. We use them because, we can use them as pilot operated. We can use them as AC or DC. Okay, and they're really easy because they're really only two states. All right, they're shifted or not shifted, and that's what makes them easy for us to control. Something is either true or it's false, right? Or it's a 1 or a 0. So those are the advantages for us to use that. Okay, and we've done some stuff with servo controls. Some of you guys maybe have already taken robotics or things like that with me, or we did some other stuff with the bobots or programming, those sort of things, all right? And we use a lot more servo controls, all right? We can use servo controls because they give us electronic, and we use feedback for self-regulation, okay? They're electronically controlled feedback for self-regulation. All of the robots that we have in class, all right, all have a servo on each axis, okay? And the large robot has 2 servos on each axis, okay? So remember, those are all 7-axis robots, okay? Proportional valves, they're electronically controlled, but they are able to position the valve between the open and closed positions, all right, allowing for precise flow and directional control. The flow rate is proportional to the output current, all right? So that's what a proportional valve is here. Okay, and last thing we're going to talk about here, just understanding pump controls. A more efficient way to control flow and pressure is to control it at the source. The source is the pump itself. Okay, so electrohydraulic pumps control the pressure and flow at the output of the pump, okay, and the only power required by the load is produced at the pump, reducing waste. So those are some different ways that we can control pneumatics, right? PLCs through sensors, solenoid valves, servo motors, pump controls, all those different type things. So this is just kind of a segment, guys, into PLC. We're going to do a couple labs on the small little trainer here so you guys can learn to, do some controls for activating cylinders and that sort of thing. But, those are just going to be the basics before we get into PLC and actually start programming all of this stuff and making it all work, in real life. So that's the good part. Else, guys, been a great semester. Like usual, have any questions, email me. Else, have a great day. I'll see you in class.